my guided solutions for the normal distribution practice. I won't be reading through the full problems, I will only be getting the needed information. For the first part, we know that somebody sitting down for a chemistry examination and physics examination scored various marks. We know that for the chemistry examination, this person had a mean of 60, well, the class scored a mean of 60 and a standard deviation of 12. Mu equals 60, standard sigma equals 12. Draw this on a diagram that shows this information. So, any diagram needs the following information. First of all, make a bell curve that looks decently symmetric and approaches the x-axis. You also need to label your x-axis. In this case, this is chemistry score. Chem scores. My mean is 60, that goes here in the middle, and your standard deviation is 12, so just make standard deviation marks on the sides, 72 here and 48 over here. Write down the probability that a randomly chosen candidate who sat for the examination scored it at the most 60 marks. 60 marks is the mean, and I want at the most 60 marks means from 60 to the left. So all I need to do is write down. There is no work required here. You don't even need Google Sheets. You know the probability is 1/2. You could have just as well have written 50% or 0.5. All of these are acceptable, and no rounding is necessary since these are exact values. We know that this person, Heejin, scored 60 marks on the chemistry examination. This is a value on the x-axis. We want to find the probability that a randomly chosen candidate scored more than Heejin. So let me make a diagram. We have a simplified diagram at least. We have our bell curve. The mean is 60, and we want to know the probability of somebody scoring more than 80. We want that side. So Google Sheets lets us calculate left tails. So all I need to do is use my norm distor function. So equals norm my x value is 80 in this case, that's a given value. My mean is 63. No, it's 60. Standard deviation is 12, and cumulative always true. This gives me a probability of 0.9522. I'm going to write this down because I'm going to use it later on. This is 0.9522. Meaning that the probability of scoring above an 80 is a complement of that, which is equals 1 minus the one up here. Always use these full digits for doing further calculations. Never use rounded digits. So the probability of scoring more than 80 is 0.4779. 0.04779. I want 3 significant figures. My first significant figure is the 4, then 7, 9. Well, 7, 7. The 9, however, doesn't make my 7 it makes my 7 round up. My final answer ends up being 0.0478. Now we're told that the candidates for their physics examination have a mean of 63 and standard deviation of 10. Heejin also scored 80 marks in this examination. We want to find the probability that somebody chosen at random scores less than Heejin. So we know that we have a new normal distribution with mean 63, standard deviation of 10, meaning that this is 53 and this is 73. Heejin scored an 80. We want the probability of somebody scoring less than Heejin. So all I have to do is update my mean and my standard deviation in my Google Sheets since the x value hasn't changed. So I change them to 63 and 10. I don't need this one anymore. So it's 63 and 10. 0.9554. 0.9554. 3 sig figs, 1, 2, 3. The 4 does not make it round up, so my final answer is 0.955. Determine whether Heejin's physics marks, compared to the other candidates, is better than her chemistry mark. We know that she has the exact same marks on both examinations. She has an 80 on both. However, I want to know in which one she did better compared to everybody else. So we want to know above the percentage of people below her in the rest of in both classes, and compare those two numbers. I know that in chemistry we have 95.2% of the people below her. She is above 95.2% of the class. However, in physics, she is above 95.5% of the class, meaning that she did better in physics. She scored above more people. Now, to obtain a grade A, somebody must score above a 10%. Actually just be in the top 10% of the class. So we have our normal distribution. Somewhere over here we have a cutting mark of M, that above this mark we have 10% of the population. If this is 10%, everything else, meaning our left tail, is 90%. We want to figure out the value of M that accumulates 90% on our left tail. We do this with the normal inverse. So we have this is in our physics examination. So we have our mean is still 63, and our standard deviation is 10. Sigma equals 10. So we have norm inv because we want to calculate an x value. So the x in this case represents the probability of getting to that a specific value. So 0.9, our mean is 63, our standard deviation is 10. Close parentheses. The minimum score is 75.81. So this value is 75.81. However, we want our answer to correct to the nearest integer. An integer is a whole number, so round it off to the nearest whole number. So minimum score of 76 is required.